Okay, in this unit, we are now moving on to equations with variables on both sides. Again, you're going to continuously see some of the information that we have, or skills that we have seen in the past two lessons. So if you look at the warm-up, this goes back to lesson 1 and lesson 2. So I'm going to remind you how to start. In order to start this problem, we have to distribute first. So I'm going to box that in. Here is what we're working with first, which means my 9x has to drop straight down. And from here, I can start distributing. I have to take my negative 4.9 and distribute to that 2x, which is a negative 9.8x. Then I'm going to distribute my negative 4.9 to my 5, which is a negative 24.5. And it all equals a negative 27.7. From here, I have to look for like terms. Here are my two like terms, so if I combine those in my calculator, you will get a negative 0.8x minus 24.5, and it equals a negative 27.7. And at this point, it takes us right back to where we were in the warm-up on 1.1. Okay, so I just wanted to review what we did first, how we distributed, what we did second, how we combine like terms to get to that bottom line. So in this lesson, it says to solve an equation that has variables on each side, use the addition or subtraction property of equality to write an equivalent equation with the variable terms on one side. So if you think about all of our other problems, all my variables were on the right. In other situations, they were all on the left. Well, now they're not going to be all on one side, and that's our main goal in order to solve. One of three scenarios will always happen when solving equations with variables on both sides. So we're going to practice. These are basic. There's no distributive property. There's no combined like terms. You can see that if you draw your line down the middle. There's no parentheses on either side. There's only two pieces on each side. So here's what has to happen. We have to move our variables to one side. We have two different variables. We have a 6n and we have a 4n. There are multiple ways that we do this. Some people like to always move your variables to the left. Some people choose the smaller one. It's going to be up to you. So I'm going to pick the smaller one. My smaller one is a 4 and it's positive. In order to move a positive to the other side, I'm going to subtract it. 6 minus 4 is 2n. There is still a minus 1, and it now equals a negative 5. Again, at this point, we're now back to this top part. Okay, I need to get that 2n by itself. Since it's a negative, I'm going to add 1 on each side. 2n equals a negative 4. I'm now going to divide to get my n by itself. So n equals a negative 2. So that's one scenario. Okay, so now I'm going to look for my variables. Here's my variables. They're the same. Doesn't matter which one we move. They're both positive. So let's subtract minus 6n minus 6n. In this case, the ones on the left cancel, and I'm left with a negative 1 equals. The ones on the right also cancel, and I'm left with a negative 5. So here's the difference between scenario 1 and scenario 2. I get n equals a negative 2 here, but I don't have any variables anymore. So then you have to ask yourself, you have to look at this statement and determine, does negative 1 equal a negative 5? No, it does not, which means this answer is a no solution. Which then brings me back to scenario 1. Because we have a variable left and it equals a number, this is going to be our one solution. So right now we have one solution because I had a variable equal a number. My variables canceled, which is why I got no solution. So now let's look at this one. Okay, I'm going to find my variables. Here's my variables. Oh, it kind of looks similar over here. Let's solve it. Since they're positive, I'm going to subtract my 6n from both sides. The ones on the left cancel, I get a negative 5 equals the ones on the right cancel, and I get a negative 5. So again, you have to, there's no variables, so it cannot be one solution, but you have to ask yourself, does a negative 5 equal a negative 5? It does. So in this case, it is infinite solutions. So let's talk about those really quick. When it's one solution, that means this is the only answer that's going to work. If I plug in a negative 2, it's going to make each side come out to be equal. If it's a no solution, that means I could ask every single student in here for a number, and it doesn't matter what number you give me, it will not work. And then on scenario 3, infinite solutions means, again, I can ask every single person in here for a number, and it doesn't matter what number you give me, it will work. So every answer possible will work here. Okay, so there are going to be times that you're going to have to identify. Our main goal is to give the answer. So if it is a one solution, you have to tell me what that answer is. You cannot just say one solution. Okay, if your variable's canceled, then you have to state no solution or infinite solutions. They're all going to be intermingled. So let's look at these first 4. These first 4, again, are basic. If you look, there's no parentheses. There's no combined like terms. We're just working on using those skills to solve like we did at the top. Okay, so on this first one, I'm going to find my variables. Here's my variables. So here's the thing. Again, this is where sometimes the rule of move the smaller one isn't always ideal. Because my 1.3c is already by itself, I want to move my 3.3 to the other side. Since it's a positive, I'm going to subtract 3.3c from each side. When I do that, I get a negative 2c, and it equals 2.8. From here, I'm going to divide by a negative 2. C equals a negative 1.4. Because we had variables left when we combined over here, that automatically told me it was a one solution. I kept going because I want to know what that answer is. Okay, so here's my next one. Find your variables. Okay, pick one of them. I don't care. I'm going to use this negative 6a here. I'm going to add it to the other side as well. My left-hand sides cancel and give me a 3. My right-hand sides also cancel and give me a 9. So again, because there's no variable, you have to give me that vocabulary. Does 3 equal 9? If you're saying no in your head, you should be writing down no solution. Remember, if we don't see a number in front of a letter, it is an understood 1. So on this one, we should see that. Here's my 2 letter B's. I'm going to subtract 1B from each side. The ones on the left cancel, giving me 4.7. The ones on the right cancel, also giving me 4.7. Since my variables canceled and my answer matches, this is an infinite solution or solutions. Okay, last one has fractions. I know how much you guys don't like fractions, but here we go. I have my 2 variables. I'm going to choose my smaller one. My smaller one is a negative, so I'm going to add 1/6x to both sides. Remember, this is why you have a calculator, so I'm going to type in my calculator 2 fraction 3 plus 1 fraction 6, and it tells me 5/6x minus 1 equals 9. Because there are x's left, I know that is a 1 solution, but I kind of keep going. So I added 1 to both sides. 5/6x equals 10. I'm going to divide by that 5/6. And x equals 12. So this is a 1 solution. And this one was 1 solution. You do not have to write down 1 solution. You have to write down your answer. So C equals a negative 1.4. That's telling me it's a 1 solution. X equals 12 is telling me it's a 1 solution. Okay, so here's part 2. Part 2, I'm going to take it to that next level. If you look, you now have parentheses. Those parentheses signal that you're going to have to distribute first. We cannot identify a solution until you have simplified. Because when you simplify, that's part of the solving process. So here we go. I always go left to right because that's how we read a book. If I have to simplify, I start there. So if we look, we do have to simplify this left-hand side. 5 times x is a 5x. 5 times 1 is a plus 5. And it equals, now we gotta look at the other side. Because I have parentheses and that extra little guy, I have to do the parentheses first. 3 times 5x is a 15x. 3 times a negative 4 is a negative 12. And I have a minus 10x. On the left-hand side, this is simplified. I cannot combine like terms. These are not alike, so I'm just going to rewrite 5x plus 5. And then over here, I have like terms. So 15 minus 10 is 5x. We still have minus 12. I'm going to subtract my 5x from the left, so it cancels. But when I subtract my 5x from the right, it also cancels. Because I do not have a variable, we have to determine if that's true or false. 5 does not equal a negative 12, so it is no solutions. Okay, same thing on this one. I have parentheses, so I have to do that distributive property first. So I get 3x plus 3. There's that minus 5 right there. And then on the other side, it's already simplified. 5x minus 2. On the left-hand side, I still have like terms, so I'm going to drop my 3x. I get 3 minus 5 is minus 2. And it equals 5x minus 2. I like to move my smaller x. That's a personal preference, so I'm going to subtract 3x from both sides. Negative 2 equals 2x minus 2. I have to add 2 to both sides. We've seen this before. My 2's cancel. I have to have a number on that side of the equal sign. So 0 equals 2x. I ran out of room, guys. I'm going to divide by 2. 0 divided by 2 is 0. Okay, let's flip it over. Let's look at number 7. I'm going to draw my line. I have to start simplifying by distributing on this side. So I have 7x plus 5x minus 5 equals. I don't have distributive property over here, but I do have 2 like terms. So I'm going to drop down my negative 5, and then that gives me a plus 12x. I can't start solving just yet because I still have my like terms over here on the left-hand side. So I get 12x minus 5, and it equals negative 5 plus 12x. Some of you guys have probably already seen the pattern, but I'm going to continue to solve. I'm going to subtract 12x. They cancel. Does negative 5 equal negative 5? It does, so it's going to be infinite solutions. Number 8. I'm not going to speak while I work through this one. I want you to try it, start it. I'm going to work through it quietly. That way you can check the steps as I work through them or after you are done. If you are done, go ahead and check your answer. If you are not, finish up. Okay, this last part, we're looking at the word problems. So we're working with variables on both sides. So you're going to see some common things happen as we read through these in common words. So it says a wireless company offers 2 cell phone plans. Plan A charges $24 per month plus $10 per minute for phone calls. Plan B charges $19.95 per month plus 20 cents per minute. Write an equation to find how many minutes, we're looking at minutes, that the plans cost the same. So they want the plans to cost the same. So we have plan A. They want it to equal plan B. So all of plan A's information has to go on the left-hand side. So let's look at plan A. Plan A charges $24 per month. I know it says per month, but we're wanting minutes. So we're just going to put 24.95. They also charge 10 cents per minute because there is your per minute. That is where my X is going to go. So 0.10x equals. Now I can move on to plan B. Plan B charges $19.95 per month. Again, since I'm looking for per minute, I'm just going to write down my $19.95 plus 20 cents per minute, which is where my X is going to go. From here, we would solve this just like we did on part 1 and part 2. This falls under the part 1 category because there's no simplifying. There's no distributed property, no combined like terms. Okay, let's look at number 10 so we can write this one. The baseball players are selling caps to their fans to help raise money for tournament expenses. The company that is making the caps is charging $10 per cap plus a $50 design fee. The baseball team will sell the caps for $15. Write an equation to show how many caps the baseball team must sell to break even. So on this one, we have the company that's making it, and it needs to be equal to what the baseball team is going to sell it. Okay, so let's talk about the company first. So the company is going to charge $10 per cap. So that's $10. We'll just keep using X. They're also going to charge a design fee. That design fee is a one-time fee. They design it, they put on the caps, they're done. Equals. Then we have the baseball team. The baseball team is going to charge them $15 each. They're not charging anything else. So again, this problem is done. On this problem, I would move the 10x because that 15x is already by itself. That's a personal preference. Okay, number 11. We have seen shapes before. We've actually seen this word before. So here we go. It says find the value of x so that the figures have the same perimeter. Perimeter means add all your sides. So they want the triangle to equal the trapezoid. So here we go. We can write this out the long way, or we can combine as we go through. So in one of the other lessons, we wrote it all out. I'm going to combine as we go through. So I'm going to look at the triangle only. I'm going to find like terms. Right now I have 2 like terms. I'm going to add them. 3 plus 4 is a 7x. Then I'm going to look for the other like terms. The other like terms are just numbers. I have 6, 7, and 10. When I add 6 plus 7 plus 10, I get a plus 23. We know we want to equal it to the trapezoid, so now it's the trapezoid's turn. I'm going to go through and combine like terms. 3 plus 2 is 5, plus 3 is 8, plus 2 is 10. So I have a 10x on this side. Add your numbers. 3 plus 15 is 18, plus 3 is 21. Again, from here we would be able to solve. Pick one of your variables, move it to one side or the other, continue through that process. Now, on this next one, this one's a little bit different. Okay, this time it says find the value of x so that the figures have the same area. And it says area is length times width. So I still want these shapes to equal each other. But instead of adding all my sides, I want to do my length times my width. So let's look at my rectangle. Okay, or square. We don't know what it is. Can't assume. Okay, so I'm going to say my length is going to be 10. And I'm going to multiply it by the width, which is x. We just said we want them to be equal. So now I'm going to do the same thing over here. I'm going to use the same pieces. So my length, I'm going to call 6. But I need the width. The width is made up of 2 pieces. So in order to get this full length, we have to add them. So this is actually 3 plus x. I have to add the left side and the right side together. So this one becomes a simplifying one. This was a basic one. Well, this we combine like terms, I guess, so it wasn't. We made it basic. So I have 10x equals 18 plus 6x. Again, this is kind of that weird one. I'm going to continue this one. I would move my 6x by subtracting because the 10 is already by itself. I get 4x equals 18. I can then divide by 4. So x equals 4.5. Okay, so on this last part is a challenge. It says fill in the blanks. On the first one, it said fill in the blanks to make this a no solution. So if we go back to our no solutions, what do you know about the variables? Well, the variables have to cancel out, which means they have to be the same number. So right now, I already know one of those numbers. On the right-hand side, it tells me it's a 5x. Well, if the right-hand side is a 5x, that also means the left-hand side is a 5x. They have to be the same for no solution. The second part of that is that constant. When we look at the constants, they cannot be the same. I can pick any number. I can call on every single one of you. You can all give me a different number. As long as it's not a -7, you're good. So let's put -4. Okay, on my next one, it says fill in the blank to make an infinite solution. So no solution and infinite solutions are going to be very similar in their variable aspect. So same thing here. If I want a no solution or an infinite solution, their variables have to be the same. So this one's a 2x, which means on the right-hand side, it needs to be a 2x. But then my constants, this is where it differs from no solution. In order for it to be an infinite solution, they have to be the same as well. So since this constant is a 4, I need to fill in the blank with a 4. And then finally, it says one solution. One solution, your variables have to be different. So right now, my variable is a 3x. I don't care what number you choose. As long as it's not a +3, you're good. So let's say 7x. Okay, then we have to look at our constants. Your constants actually don't matter at all with one solution. It's the variables. As long as the variables are different, I don't care if the constants are the same, different, opposite signs, same signs, it doesn't matter. So in reality, I can pick any number, let's just say 13. Okay? It does not matter what that back number is for a one solution.